do you know the chemicals in the stuff you use and eat are safe? Manufacturers and regulators work hard to ensure that what ends up in the things you buy isn't harmful, but it isn't easy. You can't really work out how safe something is by feeding it to people and seeing what happens next. Apart from the fact that it sometimes takes years for health problems to develop if you're exposed to a hazardous substance, experimenting on people isn't exactly ethical. This is why toxicologists use animals and cell cultures and other tests that don't involve people. They use these to explore what's likely to happen in humans, but testing a substance thoroughly still takes a long time, sometimes several years even. Partly because of this, only a few hundred of the tens of thousands of chemicals we use today have been fully evaluated. Many of the highest priority ones have been tested, but there are still an awful lot of chemicals in use today that we don't know that much about. Of course, responsible manufacturers do their best to ensure their products are as safe as possible, but the slow speed and the cost of many established toxicology tests mean that companies and regulators alike simply cannot keep up with evaluating everything they would like to. They need something better, something faster, something cheaper, and ideally something that doesn't involve using so many animals. Most importantly, they need some way of triaging the waiting list of untested chemicals to see which ones are in most urgent need of attention. A few years ago, a group of really smart people at the US National Academies of Sciences took this problem head on. The result was a weighty report with the promising title of Toxicity Testing in the 21st Century. At the heart of the report was a new idea that would speed up toxicity testing enormously while reducing the time and resources needed as well as the number of animals used. The idea was quite brilliant. If we can understand the underlying biological processes that govern how our bodies work, what the National Academies called toxicity pathways, we should be able to come up with simple tests that show how much of a given substance interferes with these processes. And if we could run hundreds of these tests really fast, we should be able to quickly get an idea of how safe or how harmful a substance is likely to be. The report was a success, so much so that the Environmental Protection Agency, the National Institutes of Health, and the Food and Drug Administration all got together and formed a massive new initiative to transform toxicity testing in the United States. The initiative's called Tox21, short for Toxicology in the 21st Century, and it's now in full swing. It was launched in 2008 with 4 aims. First, to better understand the processes or the pathways that govern how our bodies operate. Secondly, to develop tests to see how chemicals interfere with these pathways. Thirdly, to develop ways of predicting how hazardous substances might be. And fourthly, to identify those substances that are most in need of more detailed safety research. At the heart of Tox21 are 2 really cool emerging technologies: high-throughput screening and computational biology. High-throughput screening runs chemicals through tests really fast. In fact, robots are used to automatically place these substances in tiny test wells and observe what happens next. These tests are designed to indicate how increasing amounts of chemicals interfere with different toxicity pathways. However, high-throughput screening alone is pretty useless. It generates a ton of data, but on their own, these tests it uses can't tell us whether a chemical will in fact cause harm. For this, we need to integrate high-throughput screening with some advanced science and some powerful computational techniques. And this is where things get interesting. By combining high-throughput screening with advanced data processing and computer modeling, Tox21 is developing tools that are enabling thousands of substances to be rapidly screened for potential toxicity. Of course, Tox21 is just the beginning of transforming how we ensure the safety of the chemicals we use. Ironically, despite the name, it doesn't actually provide information on how toxic a substance is, just how it may behave in a complex biological system like the human body. And we're not yet sure how comprehensively it can represent the full, glorious, three-dimensional messiness of human biology. But the process is both highly innovative and incredibly important for identifying chemicals that might be harmful. For these chemicals, we still need to use animals to better understand the actual diseases they're likely to cause. And as always, we also need to understand how much of something causes harm, not just its potential to cause harm. But the more research we do on predicting what happens in animals and humans from high-throughput screening and computational biology, the more we can refine, reduce, and ultimately replace the use of animals in toxicity testing.